we have already seen DSU, disjoint set, union find data structure, right? Then we saw SCCs, strongly connected components. We saw the two pass Kosa-Raju algorithm, right? जिसमें transpose निकालते हैं graph का. I hope you remember, and you use depth first search for it, right? And we also have seen the applications of Kosa-Raju. I told you, right? It's used in finance to identify circular economy, or if a group of people or a group of shell companies is trying to inflate the price of share or increase the liquidity of a stock, right? Now let us see something called as topological sorting. Very easy, but one of the easiest algorithms I'd say, because it's very intuitive in nature. It's how humans also work. That's the reason it has wide applications in different fields, right? So firstly, let's understand what is topological sorting. Okay, it is a linear ordering. Linear ordering मतलब linear का मतलब समझता? जैसे linear data structures होते हैं ना, array, stack, queue. Why are they linear? Why is array a linear data structure?
Like in trees, they have a hierarchy that they have parents and children.
Okay, because it's non-hierarchical, parents and children होता है और there's only one way to travel. हाँ, मतलब if you are at a certain element, उसके बाद कौन सा element आएगा? Only one choice you have. Array, string, stack, even singly linked list for that matter. Yes. Right? But in the case of trees, you have left child, right child, right? So topological sorting is a linear ordering of vertices of a DAG. What is a DAG? Directed acyclic graph. Yes. We have discussed about it and it's self-explanatory, right? The graph is A directed and B acyclic. Matlab there is no cycle or loop, right? So linear ordering of vertices of a DAG such that for every directed edge u comma v, every directed edge u comma v, matlab edge is starting from u going to v. U से start होके V तक point कर रहा है वो, right? So for such that for every directed edge U comma V, U comes before V in the ordering. मतलब आप linear order print करोगे वो पूरे ग्राफ का, क्या होंगे उसमें? सारे vertices होंगे. जैसे ग्राफ बहुत बड़ा है V3, V4, V5, V6, V1, V2, V4, V8, V9 and whatnot. But it's a DAG. Directed graph and acyclic है, there's no loop in it. Then topological sort would be a serial ordering or a linear ordering of vertices. कि भाई सबसे पहले तो V2 करना पड़ेगा. Then you can move on to V4, V3, V5, then V1, then V7, then V9, and then last में V8 or something of that sort. Did you ऐसे on a surface level get what is topological sorting? It is linear ordering of what? Of vertices. Vertices किसके? एक डैग के, ठीक है? कैसे? ताकि अगर वो डैग में U से V तक अगर कोई डायरेक्टेड एज है तो आपकी लीनियर ऑर्डरिंग में U शुड ऑलवेज कम बिफोर U शुड वैसे भी ऑलवेज कम बिफोर ओनली. U should be all right. Let's come back to this. So there are only two conditions. Directed होना चाहिए. क्यों? क्योंकि directed ग्राफ ना it represents dependencies. So whenever there is an edge from U to V, application wise अगर देखोगे तो it represents a dependency of V on U, of V on U. जैसे अगर मैं बोलूं कि मशीन लर्निंग एल्गोरिथम पढ़ने से पहले मशीन लर्निंग या आर्टिफिशियल इंटेलिजेंस, like if you want to study ML or AI, before that there are some prerequisites. Let's say linear algebra, permutation and combination, some statistics, determinants, matrices, probability, right? So all these are what? Prerequisites. मतलब अगर if you want to study ML algorithms, इसके बाद फिर ML में if you want to study linear logistic, SVM, neural networks, backpropagation, right? LLMs, anything. Before that, ये सारी चीजें आनी चाहिए. Yes. So these are what? Prerequisites to learn this. So if I plot a graph for a computer science student on his journey of learning all the subjects, तो बहुत बड़ा ग्राफ बनेगा. Operating system, compiler design, computer networks, right? Logic building, DLDA, gates, and or not. मतलब many such subjects would be there, right? If I plot a graph of this, there'll be directed edges. So कहीं पे तो ML, artificial intelligence के पहले ये सारे ये points होंगे, mathematics, probability, PMC, linear algebra, and there will be an edge starting from this towards this. So this is a directed edge. Why? Because it shows dependency of this on this. कि ये करने से पहले ये सब करना जरूरी है. Are you getting this? So everywhere when you find that the problem can be represented by graphs, like nodes and edges, directed edges, then you could think of topological sorting to identify कि कहाँ से start करें, कहाँ खत्म करें. Right? So if I plot a graph of all the subjects you need to study in computer science and all the dependencies, कि इसके पहले ये आना चाहिए, then you could give your junior a proper linear order में all the subjects that she should study. Are you getting? Pakka? Everyone clear?
Yes, sir.
Alright. So there are two conditions: directed, right? The graph should be directed and it should be acyclic, and that is nothing but that. Right? Very clear? Super. Let's see an algorithm which helps you find out the linear ordering, the topological sort. It's a sort, right? But of topology. Topology पढ़ा होगा आपने geography में. Right? So it's a topological sort. आप return क्या करोगे? A list of vertices. Yes or no?
Yes, sir.
Right? What's the name of the algorithm? Right? Okay. So, firstly, I hope you know that in directed graph there is something called as in degree and out degree.
Yes, sir.
पक्का पता है?
Yes, sir.
In degree मतलब कितने edges आ रहे हैं? Out degree मतलब कितने edges
Coming from
जा रहे हैं?
this.
Right. So, first thing you do is calculate in degree. In degree is nothing but number of incoming edges. Very easy. It's very easy, right? Edges आपने store कर रखे होंगे adjacency matrix या list या जैसे भी, right? आप हर एक vertex के लिए देखोगे कि कितने edges उसकी तरफ point कर रहे हैं. तो सारे vertices का degree आपको पता है? Yes or no?
Yes, sir.
Yes. Now just think very logically. अगर आपको topological sort निकालना है, तो वो topological sort is starting from some vertex. कोई ना कोई स्टार्टिंग वर्टेक्स होगा ही. स्टार्ट वर्टेक्स की क्या खास बात होगी? What will be something unique about the start vertex?
उससे पीछे कोई स्टार्ट.
Exactly. वो किसी पे डिपेंडेंट नहीं हो. अकेले ही हो. तो be like start vertex. Never be dependent on someone. Right? क्योंकि उसके पहले अगर कोई होगा तो there's a prerequisite, right? If I'm starting from that, जैसे maths, if you wanna study computer science, mathematics is what you start with, right? Physics is also. If you look, I'll tell you something very interesting. I had a discussion and one of my professors told me just day before yesterday. We had a call at 11:30 or something, and we were discussing normal क्या चल रहा है कैसे चल रहा है. Then he told me कि Sushman, you know what sir? And he has taught me physics. ठीक है, super great, awesome, alpha guy. Right? मैंने सुषमा तेरे को पता है? मैंने बोला क्या सर? तो बोले मशीन लर्निंग इज नथिंग बट अ वेक्टर. मैंने बोला सर 11:30 बजेगा. मेरे को इतना पता है कि मशीन लर्निंग इज मैथ्स, प्रोबेबिलिटी एंड स्टैटिस्टिक्स. व्हाई वेक्टर? तो उसने बोला व्हाट इज अ वेक्टर? मैंने बोला डायरेक्शन एंड ये. मैंने बोला नो, वेक्टर इज जस्ट अ पॉइंट इन स्पेस, राइट? इफ इट्स अ 2D or 3D or 4D or something, right? You draw a line from the origin so that you could perceive it in the space. But आप origin से line सिर्फ 2D 3D में ही कर सकते हो. 4D में तो you can't represent, right? It will just be 4 numbers which gives you the vector definition, right? So then we discussed and then he told me that then if it's a 100 dimension, if there are 100 dimensions, so one vector will have 100 values and multiple such vectors. You will represent in what? a determinant, a matrice. You'll represent it in what? Matrix. Right? And multiple such vectors means multiple matrices, and that is what you do in machine learning, right? GPU कैसे? How does GPU process? Matrices only, right? So yeah. So let's come back to this. So what's the uniqueness of start vertex? कि उसके पहले कुछ नहीं है, right? And that's the reason you can start from there, right? So you calculate all the incoming edges. You initialize the queue. जो आप रिटर्न करोगे सॉर्ट में, क्या क्या डालोगे उसमें? Add all nodes with in degree 0. In degree 0 का मतलब ही क्या होता है? No dependency. You could start with anything. There could be multiple such nodes which have in degree 0. उसमें से कोई भी randomly choose कर लो, क्योंकि कहीं से भी start कर सकते हो ना. Let's say maths है और physics है और कुछ है. Suppose दो है जिनका कोई prerequisite subject है नहीं, तो a student can start with mathematics, the other student can start with physics, and then आगे it depends, right? So do you get this? There are multiple sorts possible for same graph, topological sorts. Are you very clear on this? Super. So you initialize the queue. Now see, this process is very easy. How do you process the queue? Add the first node u to the topological sort list, your start vertex. Then for each neighbor v of u जहां point कर रहा है, मतलब उसके बाद आप क्या कर सकते हो? मतलब ऐसे vertices जिसका dependency was u, and since you are done with u, you could move on to v1, v2, v3. Let's say there are edges u to v1, u to v2, u to v3. So now since u is done, you could move on either to v1 or v2 or v3, anything you want. Understood? Provided कि v1, v2, v3 का कोई और edge नहीं है. If v1, v2, v3 तीनों का in degree 1 है, मतलब there's only one edge incoming, and since you are already done with u, अब v1 का in degree क्या हो जाएगा?
0.
Yes or no?
Yes.
Zero हो जाएगा, क्योंकि u तो आपने consider कर लिया, तो you could move on to v1, v2, v3. That is exactly what the algorithm does. Firstly, you add the first node u to the topological sort list. Clear?
Yes.
Then for each neighbor v of u, firstly क्या करोगे? Decrement the in degree of 1, because u is already processed, so that dependency is done, over, taken care of, right? So you decrement the in degree of v, and if in degree of v becomes 0, तो क्या करोगे? v भी q में ऐड कर दो ना. Yes or no? And obviously you repeat this again and again until the q is empty, और एक लिस्ट में ऐड करते जाओगे वो लिस्ट you would return. Very clear, very easy code. स्टार्टिंग में for loop लगेंगे इन डिग्री कैलकुलेट करने के लिए, एक क्यू बनाओगे, राइट? और हमेशा डिक्रीमेंट करते रहोगे, while यूज कर लो लास्ट में, while q not equal to empty. Yes or no?
Yes.
Very clear with the code. Let's just see one example on this. Suppose this is an everyday example. If I have to create a tag of clothing, तो सबसे पहले अंडरशर्ट पहनोगे फिर शर्ट पहन पाओगे. Yes or no? मतलब डिपेंडेंसी है. So first undershirt, then shirt. First shirt, then only you could put a tie. You can't put a tie and then wear a shirt. First shirt, then only you could put a jacket, tie, and after that jacket, right? Socks, then shoes, undershirt, and then shoes. If this is what the dependency list looks like. Then if I create a tag, U means undershirt, S means shirt, SO मतलब socks, SS मतलब shoes, T मतलब tie, J मतलब jacket. It will look, the tag would look something like this. You have an edge from U to undershirt to shirt, undershirt to shoes, socks to shoes, shirt to tie, tie to jacket, shirt to jacket. अगर ये थोड़ा सा उल्टा होता ना कि जैकेट पहले शर्ट बाद में, तो टैग ही नहीं रहता. Now you could do a topological sort on this because it's not a tag, and it's very intuitive, right? अगर tag है suppose कि physics सीखने के लिए maths आना चाहिए, maths सीखने के लिए chemistry आनी चाहिए, chemistry सीखने के लिए physics आना चाहिए, तो कोई बंदा कुछ सीख ही नहीं पाएगा, right? जैसे आज का मार्केट कंडीशन है, जॉब पाने के लिए एक्सपीरियंस चाहिए और एक्सपीरियंस के लिए जॉब चाहिए, तो इट्स अ क्लोज लूप, राइट? deadlock, right? So since it's a DAG, we could apply topological sort. Can you tell me सबसे पहले क्या करोगे? कुछ भी कर लो, अंडरशर्ट पहन लो, सॉक्स पहन लो. अगर नॉर्मल बंदा है तो पहले अंडरशर्ट पहनेगा फिर सॉक्स पहनेगा, नहीं तो पता नहीं कोई होगा जो उठते ही पहले सॉक्स पहनेगा, राइट? तो फर्स्ट यू कुड गो फॉर अंडरशर्ट, देन शर्ट, right? Then tie, then jacket, then socks, then shoes, right? Or else you could go undershirt, shirt, socks, shoes, tie, jacket. Or undershirt, shirt, socks, tie, shoes, jacket. Multiple such possibilities are there, right? क्योंकि see, let's try. मतलब पहले के लिए कितने ऑप्शन है? 2 ऑप्शन है, right? अंडरशर्ट या सॉक्स, दोनों में से कोई भी you would choose. सेकंड के लिए अगेन you have 2 ऑप्शंस, either शर्ट और शूज, either शूज और शर्ट. थर्ड के लिए इट्स ऑब्वियसली टाई और जैकेट, दोनों पॉसिबल है, राइट? यू कुड वेयर अ जैकेट एंड देन वेयर अ टाई. इज दैट पॉसिबल? पहले जैकेट एंड देन टाई? नो, बिकॉज़ देयर इज एन एज फ्रॉम टाई टू जैकेट, ऑब्वियसली. तो इसीलिए पहले जैकेट, इसलिए पहले टाई आएगा और जैकेट, ठीक है? The multiple such possibilities. And see, if you see last end vertex कौन सा होगा? जिसका out degree 0.
So
yes or no? तो shoes भी हो सकता है या jacket हो सकता है, right? There are various applications of this, right? Even compiler uses this to generate the sequence of instructions, the instruction sequence of the program that is being executed. एक प्रोग्राम है जो एग्जीक्यूट हो रहा है, मल्टीपल इंस्ट्रक्शंस, बट देयर कुड बी डिपेंडेंसीज ऑफ इंस्ट्रक्शंस, राइट? सो यू जनरेट टोपोलॉजिकल सॉर्ट व्हिच गिव्स यू लीनियर ऑर्डरिंग ऑफ इंस्ट्रक्शंस, राइट? रिसोर्स एलोकेशन, अ लॉट ऑफ स्टफ. ऑलराइट, आई होप दिस इज वेरी क्लियर. यस और नो? एनी डाउट्स? कैन समवन टेल मी टाइम कॉम्प्लेक्सिटी ऑफ दिस? इंटीग्रल कैलकुलेट करने के लिए कितना टाइम लगेगा? नंबर ऑफ एजेस है ना, जितने एजेस होंगे हर एक एज से आपको इंटीग्री एक पता चलेगी. तो O of E एंड Q प्रोसेस करने के लिए can someone tell me time complexity of this rather than telling me? अच्छा, what's the time complexity of topological sort? O of V, O of E और O of V plus E?
V plus E.
गूगल करो, चेक करो. V plus E है तो फिर मेरे को स्टेप वाइज बताओ कहाँ पे V आ रहा है, कहाँ पे E आ रहा है. फर्स्ट वन को आई टोल्ड यू इंटीग्रल कैलकुलेट करने के लिए O of E लगेगा या O of V लगेगा?
Integrate.
What if the number of edges are more than number of vertices? तो O of E या O of V? अगर 3 वर्टाइसेस है, अगर लेट्स से 4 वर्टाइसेस है और बहुत सारे एजेस है, 1 to 2, 1 to 3, 1 to 4, 2 to 3, 2 to 4, बहुत सारे एजेस है, 4 वर्टाइसेस और 10 एजेस, तो O of B लगेगा या E लगेगा? Tell me the time complexity to calculate in degree of all the vertices. Is it O of B or O of E? What you should think of is both the cases. Cases where vertices are more, जैसे graph is very sparse, मतलब 100 vertices है और सिर्फ 50 edges है, और graph is dense, 10 vertices है और 50 edges है या 20-30 edges है, right? So think in terms of that. Firstly, what's the time complexity of KAHNs algorithm?
V plus E.
V plus E, sure?
Yes sir.
मेरे को सिर्फ इंटीग्री का बताओ ना कितना है. So that is the reason it depends on whether vertices ज्यादा है या edges ज्यादा है. अगर vertices 10 है और edges 3 ही है, बट आपको 10 के 10 vertices पे चेक करना पड़ेगा ना इंटीग्री कितना है. Yes or no? Okay. So yeah, so that's the time complexity. This is again O of E only, क्योंकि for every neighbor B of U, worst case में ऐसा हो सकता है कि सारे एजेस यू से ही स्टार्ट हो रहे हैं, तो ओ ऑफ वी एट मैक्स वी, राइट? So that's the reason time complexity comes out to be v plus e. Yes or no?
Yes, sir.
Very clear?
Yes, sir.
Super.